Let's finish lesson 5-3. Before we go too far, remember that we are finishing up equations that have slope-intercept form, and here it is. Y equals mx plus b, where m is your slope, b is your y-intercept, and if anything that I just said confuses you, I think you should probably go back and watch 5-3 part 1. So, if you are given 2 points, such as 2, 1, and 5, -8, you can figure out the equation for the line. How do you do it, you ask? Well, start by figuring out the slope. You've got 2 points, so you can figure out the change in y over the change in x, and then reuse one of those points, it doesn't matter which one, to solve for b. This one, we figured out a slope of -3, and then we picked 1 point, in this case, 2, 1, put it back into the equation, and solved for b to come up with 7. Read through this more slowly if I just did it too fast. And when you're ready, you try, got it, number 4. So we're given these 2 points. First thing we have to do, figure out the slope. Change in y over change in x is 1/2. Then, using our slope-intercept form, we can put 1/2 in for m. We can pick either point and substitute in for x and y. I chose this point. You can test it out with this point, you'll come up with the same answer. So if -3 equals 1/2 times 1 plus b, then b will be -3.5, but we are not done yet, because what I'm looking for is the final equation of the line, right there. The slope that we figured out at the beginning, the y-intercept that we just figured out, x and y. Isn't that pretty? So given the equation, can you create a graph from it? Of course you can. Y equals 2x minus 1. You've got the y-intercept, which is -1. So plot that point. And then you can just do that rise over run trick. If the slope is 2, that means up 2 over 1 and get a second point. Once you've got 2 points, you can figure out the line. You need a straight edge though. 2 equations here for you to try it with. Number 5, A and B. You know what to do. I'm on page 309. They've got a problem about a scuba diver. Someday, I want to go scuba diving. They are telling you that you can use information presented like this to create an equation in slope-intercept form. So you're given this fact that at 0 meters, the atmospheric pressure, or ATM, is 1. But as the diver goes down, the pressure increases by 1/10 of an ATM per meter. So because you've got this at 0, the pressure is 1, that gives you a y-intercept. And this gives you your slope. Your slope is 0.1. So put that information into our slope-intercept form, and you got a graph. That was pretty straightforward. The thing I really like about this is you were actually doing this kind of problem earlier this year, and for some of you it was very easy to turn this into algebra, and some of you we kept having the discussion, well, but why can't I just do it using math? And I would say, but you need to do it my way if you'd like credit for it on the test. Well, this time, same exact kind of problem, but please put it into slope-intercept form. The plumber charging $65 for a repair is another way of saying, here's your y-intercept, this is where we're starting. Plus $35 an hour is another way of saying the slope on your graph, the rate of change, is going to be 35. So there's your equation. Let's turn this into a graph. Check out the scale that I used on this graph. I thought about this a little bit so it would make sense. Y-intercept is 65. If I go over 1, and I use 2 squares for 1, and then up another 35, I'm right below 100. There's my second point. Grab my straight edge. Notice this is only the positive quadrant because the plumber is not going to get negative money. The plumber is not going to pay you to come fix your leaky pipes. Line them up. Draw a nice straight line. And there you go. Your classwork for your next class. Looks like that. It's a fair amount of graphing. You will need graph paper and a straight edge.